we are finishing 5.1 here, and we're doing the extreme value theorem. Just make sure that the function is continuous, and I'm trying to give you a good idea of what's happening on f of x. With a lot of experience, you get better at this, because as you look at the cube root, we can cube root negatives. It's just that when we square them, they end up, the graph looks kind of wonky. It's shifted left 2. You should be familiar with that. But it has like this, almost like a bird, like, the old school way of drawing a bird. But anyway, the function is continuous. So I would appreciate seeing that you're acknowledging that the function is continuous everywhere. That way we can move forward and we can actually do the extreme value theorem. So if it's not continuous, there's really not any point to doing this. So let's start with the derivative. Once we establish that it's continuous, bring the 2/3 in front, doing the chain rule, to the negative 1/3 power, because 2/3 minus 1 is negative 1/3. And then the derivative of the inside is just 1. If you wanted to write down times 1, that's fine, except times 1 does not change any values. It might be worth your while to point out, though, that this is 2 over 3 cube root of x plus 2. And to that end, the numerator can never equal 0. Let me just change colors just real quick. The numerator can never equal 0, so it's never going to have a horizontal tangent. But if you set the denominator equal to 0, that's going to tell us at x equals negative 2, f prime of x does not exist. But it could be a relative, it is a relative extrema, and to add to that, it could be an absolute min or max. So how do we test it? Well, the extreme value theorem tells you to do f of negative 3, f of that value we just found, first endpoint, all the values in between, and then also f of 6. The smallest number that you get will be your absolute min, and the largest number you get will be the absolute max. So I think you could do this in your head, because negative 3 plus 2 would give me negative 1. The cube root of negative 1 would be 1. Negative 1 squared is positive 1. Or you could use a calculator. Plug in negative 2 plus 2 is 0. To any positive power is still 0. And then plug in 6 plus 2 is 8. The cube root of 8 is 2. To the second power would give me 4. So as we examine our 3 values, the smallest is 0. And you probably could tell that before I even started doing the problem, because I gave you the graph. There's an absolute min value of 0. And like I said, you typically don't have to, but it is nice to see the x value. And then the absolute max value is 4 at x equals, did I write down the right number? I guess I did, 6. So very, very, very important. And you might be sitting there and saying, well, where's my justification? This work is justifying it. If anything, you could say, this is by the extreme value theorem. Because you're showing the reader that, hey, I checked where the derivative is 0. Well, it didn't equal 0 anywhere. Where the derivative does not exist. Boom. And also the endpoints. So you're showing your work that leads to the extreme value theorem. Make a comma then. The absolute min. Yada, yada, yada. Well, as we look at number 4, just a friendly reminder about the continuity is, remember, you can only log positive numbers. Well, if you were to try to do that, what happens if x equals 2? Well, if x equals 2, which is in this interval, we'd be doing the log of 0, which is not possible. Not possible for x to be 2. So continuing on would be a moot point because the extreme value theorem does not apply. There's some sort of gap in the graph, and you can use a graphing calculator. You can check this out. Because h is discontinuous. Specifically at x equals 2, but more generally on the interval from -1 to 3. If it doesn't apply, then how are you going to show the work that would lead to that answer? Well, you can't. So at this point, I know this is a 3-video lesson. Maybe it didn't have to be, but you should be ready for the homework, which good luck on.